Hello everyone, I'm Tang Hongjie, and this is the program for Lab3 2C. So we combine the program 1 and program 2 into this. So this is the data for the variable to output the menu, and this is used to store the user section. And this is the program 1 variable. Site hex1 is to store the site length of hexagon 1. Site hex2 is to store the site length of hexagon 2. Perimeter hexagon 1 is to store the result of calculation hexagon 1, and perimeter hexagon 2 is to store the result of calculation perimeter hexagon 2. Total perimeter is to store the result of sum of the perimeter hexagon 1 and hexagon 2. So here, the title str is to show the title for the program 1, which is calculate perimeter the two hexagon using loop and add instruction. So input str1 is to prompt user to enter the side length of first hexagon. Input str2 is to prompt the user to insert the side length of hexagon 2. Result title will be used to output the calculation result of perimeter hexagon 1 and hexagon 2 later. And total title is to output the total perimeter of hexagon 1 and hexagon 2. We will use it in our code later. Now we proceed with the main program here. First is the main menu loop. So we implement and call clr_scr to clear the screen to make the output is more clear before we display the menu. So after this, move edx offset welcome message. The address of welcome message is go into the edx, and so edx change. So we can call write string to write the string in the welcome message. And after this, we call clrf, so it can move to the next line and next line to display a good format menu. And here we use same method, so it output like this. So this also implement the same method, move to edx and call write string. All of this menu is right after this, and here it is the output, and we call read dec, read decimal, so to get the choice from the user. As we want to use program 1, so we enter 1 in this input, and after read the user input, it will store in eax, and we call clrf again to make the output later will be in the next line. Here the move selection in eax also move the user input just now into the selection. Now we compare the selection with 1. If it is 1, so je query hex look at, so means it will jump to the program 1. So here it jump to the program 1 here, and then after this we use move edx offset str title str to display the program 1 title like this. This is all the same method. We want to get the output here like this. So we want to prompt the user here, and here is the output prompt. Then we call the read decimal here. So we want to enter the hexagon length, side length. Here we enter 8 here. Then proceed. Next, what we entered just now, it moved to eax, and here move edx offset input string 2, where we want to get the second side length of the hexagon 2. So I enter 19. After this, we call again clrf to get the output to the next line. And here we want to calculate the perimeter for hexagon 1. We first initialize the loop counter here, and then we clear the accumulator, so we can calculate in the add eax side x1. So we add the side length of the hexagon 1 into the eax. So this is the first side for it. So the loop L1 is the end of the loop, so it will come back to here and decrease the ECX, which is the loop counter. So we keep adding and decrease the counter for 6 times. The perimeter of the hexagon 1 is fully calculated. And for the hexagon 2, also the same logics. We initialize the loop counter, and here we need to clean the accumulator again. And here also add side hex 2, so we can edit, calculate the perimeter hexagon. And here loop L2 is finished, then it will decrease the loop counter and repeat to get the perimeter here. When the counter is 0, it come up to the next. So move perimeter hexagon eax, so it store the result into the perimeter hexagon 2. Just now also it moved to the perimeter hexagon 1 eax, so just now it store all the result into the perimeter hexagon 1, and now we want to store into perimeter hexagon 2, so all the result is stored all in the variable here. Now we want to store the result in eax into the perimeter hexagon, so it can store the perimeter from the calculation into this variable. Then we proceed, and we want to calculate the total of the perimeter from hexagon 1 and hexagon 2, so we move eax perimeter hexagon 1, where we move the value of hexagon 1 perimeter into the eax, and we added with the perimeter hexagon 2 using this sign, and we move the result of calculation into the total perimeter to be stored in this variable. Next, so we implement this one of move edx offset result title. So the result title is the address. We'll move in the edx, so we can call write string to write the result title into the output here. And here we move eax perimeter hexagon 1, so the hexagon 1 perimeter will be moved into eax. Now we can call write decimal, and it will output the perimeter. Same goes to the next one. We just move the perimeter hexagon 1, 2 into eax and call it to write in the user interface. So after this, offset total title to write the total title, and we move total perimeter into eax. Here is the output for the total title, and we move. Here we write the total perimeter, and it will ask for continue. We want to give the message h to prompt the user if they want to continue the program, and we write string. The prompt is written, and we want to continue, so we enter y. So it print the y into this, yes. So after this, we call clrf and move to next line. So we compare the character enter just now. This we store all the character we enter and move in chart in. The chart in compare with y. So it is the input compare with y. And if it's not y, it will jump to exit program, but we enter y. So it read the chart. and this will clear the leftover enter key after user press Y and enter. And here we call CRF and jump to the main loop again, main menu loop again. So here, as I said just now, the clear screen is work now. It's clear the screen. So it output again the menu. So here, read the choice. If I enter an invalid choice here, so it will, like the same logic just now, move to the selection, store the selection into this variable and compare one not, so we will not jump into program one and compare to not the program two, so it will just ignore, then it will pop up, it will goes to offset invalid message, move EDX, so it can write the string for invalid message, so here, and ask to continue again. If they want to continue, here, it jump to here, just now the ask continue function, and we don't want to continue anymore, so enter n is the prompt, so we go, it detect this not y, so it jump to the exit program, and move offset thank you message. So it will write the string, output the thank you message, and that's the end of the code.
Hi, my name is Quentin. I'm going to talk about the part 2C. Since I'm student 2, I will only be in charge of the program 2. So this is the code. You can see that it is the menu string, so all of these variables will store the strings. You can see it's in byte because we have the now terminator at the end, and it will store all of these strings. Then the next one is the user selection storage. So these variables will store the user input. The first one is the selection. This will store 1 or 2. So for example, if the user enter 1 to calculate this one, you prompt them to the program 1, and this one you prompt them to the program 2. So I'm only going to talk about the program 2. And this one is the select input. Is the user will enter their input, then the input will be stored inside this selection. Then this continue message to press Y to the main menu. So this will loop the program again, or N to exit the program. The user input will be stored inside this char in because the char in stores the capital Y or N. This thank you message will be prompted when the user press N, and this invalid message happens when the user does not enter 1 or 2. For this prompt select, they press 3, 4, 5, 6, 7, then you will get this message using invalid choice. Please select 1 or 2. I'm not going to talk about the program 1 variables. I'm going to jump straight into the program 2 variables. The first one is the hello, which I already explained earlier. It's the array that stores 6 integer values. Then we have a total, even, and total odd. This will store all the even numbers, including all the even indexes, integers in hello. And this one is the odd. And the next one is the header, prompt, message result, message even, message odd. All of these variables are also present in the program 2 that I demoed. Now I'm going to show you the debugging. Okay, so you will inside EDX, and then you will change the values. Then this as well, you can see that the string store inside EDX change values. So I'm going to skip this. This one bottom is the prompt select. So after that, you will prompt the user to enter select the input. So for my case, I'll press 2 since I'm in charge of program 2. Now the next one is you will move into the selection, which will now store 2. The EX will also be 2. After moving the selection will be 2. Then we clear line. Now we'll start comparing because we press 2, so this one will be skipped basically. Now you will compare the selection of 2. So if you see code, you will jump to the call sum odd even, which it will. Now we can see it's jump towards the call sum odd even. Now you will move the header into EDX, so EDX value change. Then output in line, and then move the Z6, which will store all the inputs. I mean, you use for the input loop, which I already explained. And then the ES I remove 0 because starting from 0, then 4, 8, 12, 16, 20, and so on. So now you will ask me for my input, and so on and so forth. This is basically the same as the program 2, so I'm not going to explain it. So after the 6 loop, you will start to count the even indices. It's 3 because there's only 3 even and 3 odd. So start from 0, and then EX is 0 plus accumulator, then we add the hello is, so this the accumulator, so the hello is how we will start adding inside EX. So you can see the hello is 15, which is the 21 here. After converting into the hexadecimal from this decimal 21 is 15 hexadecimal. Then we'll move inside the EX, so now EX 15 and plus EX 8. So the next one will be hello 8, 9, 10, 11 plus inside EX. Then you see the next one will be EX 17. After we add the values, then we come 17, then we plus with the 8 again, and then we come 3 because the hello EX add inside EX, and so on and so forth. After that, after the loop, we move the EX inside the total even. Then we do this for the odd, which is basically the same thing. We add the hello inside EX, except that we start from 4, so this one will start from 4, 12, and then 20. This one will be 0, 8, 16. Then we do the loop for all 3. Now the accumulated EX will be stored inside the total odd. So we will become this, so this is the total for all the odd indices. So after adding everything, we will display the output. The message result will be stored inside the EX. As you can see, it's all the strings. Then we will do the new line, then we will print the output. Then after that, we will store the message inside EX. As you can see, the value has been changed. Then we print the EX, the message even message. Then we print the output. Then we move the total even inside EX. This is the total number of the even indices. You can see the EX now is A3 because for the even is A3. Then we call the right decimal, so this will basically bring the output to some header is 163, as you can see, because the A3 will be converted into the 163. Then we call the new line, then we move the message out inside EX, then we output it, you can see, and then we move total out inside EX, then we write decimal, so this will output the decimal value of the total odd hexadecimal. You can see C6, then we move inside EX and C6, then the output you can see now is 198, and then we do the new line. Then the next one is the ask to continue. We will store the continue message inside the EDX. So EDX now will have very high value, and then we output the message. You can see now it's YN, and then we'll call the 8 character. So what this will do is that we'll need to alter a value. For example, if I enter n here because I want to end it, then it will call the right char so that I can see my own value is on. Then we move the n inside the char in, then we press the line, we compare with one. So if it is not char is not equal to 1, then we'll jump to visit program. Because ours is n, so it will definitely jump to visit program. So after that, we can see this the offset thank you message. Move inside EDX, then let's see the value has been changed, then we output the EDX. We'll show here thank you about. And then the next one, new line, and then that's it. So now I'm going to show the final output. So I'm going to debug. Okay, so this is the final output. This is the menu with the welcome to single math activities. Then this is the main menu. Then it will display the two options. The first one is the prompt to program 1. This one is mine, so program 2. So I'm going to select which 2. After entering the 2, then I will go to the program 2. The variables, the header, the calculate sum, then integer code. For example, I will add this values. Then after that, it will display the result sum here. Then also the sum hero in the next location, and also the tip of so this even refers to the 21, 43, and 42. So if you add them together, it will become 106. And then the output will be 78, 91, and 71. Plus together will become 240. Then I can press Y N. So in the case of press N, so after pressing N, you can use the thank you by is the thank you message, which is shown here. And then this is the final output.